Okay, hi everybody. So first we'll write out the first 5 rows of Pascal's triangle, whatever that is. So these problems on the problem list that you're going to quiz yourself on repeatedly and repeatedly and repeatedly are just really chosen so that they become like your friends. Like these examples will become second nature to you, and it'll make your life much easier as we go throughout the course because these things will keep coming up. And so it's worth the time. So let's take a look at Pascal's triangle. What is it? So 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 4 plus 6 is 10. 4 plus 1 is 5. And I don't even know how many rows this is. Maybe that's enough. Anyway, you could keep going until you're sure that you have enough rows. Okay. So that's part A. Now let's calculate x plus y to the n. So x plus y to the 1 is the easiest. That's just x plus y. Okay. X plus y to the 0 is defined to be 1. Okay. X plus y squared, well, that's just x plus y times x plus y. And now we can take this whole thing and maybe distribute it through. And we'd get x times x plus y times x plus y. And then we take this and distribute it through, and this and distribute it through. And yx is equal to xy. If these are numbers, if these are linear operators, it might not be equal. If these are quaternions, it would not be equal. But if these are complex numbers, real numbers, rational numbers, integers, these two are equal, and we can write 2xy. Okay, so anyway, this is equal to this. Good. All right, let's do the next one. X plus y to the third, well, that's x plus y squared times x plus y, which is, well, we already calculated x plus y squared. So it was an x squared, and then this is going to come through and hit each of these 3 terms. Right, there are 3 terms here. Do you know this word? 3 terms. A term is something that's being added together. Whereas like 2xy has 3 factors. This, because these are being multiplied together, we call them factors. And yeah, anyway, so x. This is all a bit tedious, but in the end, we're actually going to just skip all this and just sort of remember how it goes. I'm freely using the fact that I can any of the factors in one of these terms. I can rearrange any of the factors in any order because I'm thinking that these are, like, let's say, real numbers or complex numbers. If these were quaternions, that wouldn't work. Okay. Or if these were matrices, that wouldn't work. Now I have to probably gather things. So I have x to the third. How many x squared y's do I have? 1, 2 more. That's it. So I have 3 in total. Oh, 1 plus 2 is 3. And I have 2 plus 1, xy squareds. That's 3 xy squareds. And I just have... oh, that should be y to the third. Yeah. Interesting. 2 plus 1 is 3. 2 plus 1 is 3. Great, let's do x plus y to the fourth. How many do I have to do? Oh my goodness. Oh, I only have a couple more. That's all right. Okay, so now I have, well, I have these 4 terms, and then one more, because I have x plus y to the third times x plus y. So let's just do this, x plus y plus 3x squared y times x plus y plus 3xy squared times x plus y plus y to the third times x plus y. Okay, so let's do this. X to the fourth plus x to the third y plus 3x to the third y plus 3x squared y squared plus 3x squared y squared plus 3xy to the third plus another xy to the third plus y to the fourth. Okay, now let's gather them together. I have 1 x to the fourth, and then 1 plus 3 is 4. 1 plus 3 of the x to the third y terms come together and give me 4x to the third y. 3 plus 3 gives me 6 of the x squared y squared terms. I have 6 of them from the 3 plus 3. And then 3 plus 1 is going to give me 4 of the x y to the third, and I have only 1 y to the fourth. 3 plus 1 was 4, 3 plus 3 is 6, 1 plus 3 is 4, and that is exactly what we were seeing in Pascal's triangle. So right away, I can just look at this and say, look, x plus y to the fifth. If I want to avoid all this work, you see I'm going to have to do even more work. I can avoid that work by just noticing that Pascal's triangle is encoding this pattern for us. And so why don't I just use it? It's going to be x to the fifth. It's 1 x to the fifth. How many x to the fourth y's? There will be 5 of them, and it'll be 1 plus 4 when I expand out. There will be 10 of the x to the third y squared terms. Remember, this is degree 5. I'm raising it to the 5th power, so there's always going to be 5 total variables. It's just like how many x's, how many y's. And anyway, so 10 x squared y to the thirds plus 5 xy to the fourths. Oh, I'm running out of room. Still, this is much easier than the other way. And finally, a 1 x or y to the fifth. And that's it. I did it. Thank you for watching this fascinating thing. You should really just do this a lot, because the faster you are with this, the better the rest of the class is going to go. Not only are we going to have to do like x plus y to the fifth, but like later for Taylor series, we're going to have to do, well, first of all, we're going to have infinite summations of some derivative at a point, but we're going to multiply it by x minus a to the n. And n is going to go to infinity, and we're going to have to divide by n factorial. And anyway, like, this is, you might as well just get used to these kind of things. They're super useful. So this is called Taylor series.